All right, guys, I'm here with Sergey. I am super excited to talk about smart contracts today with a bunch of the work you've done. Thank you for coming.
Yeah, thank you very much for having me.
For sure. Let's go through your background real quick so that everyone kind of knows the perspective you're coming from, and then we can kind of jump into some of the projects you're working on and how smart contracts will be implemented throughout the world.
Yeah, of course, makes sense. So we've been building smart contracts for about 5 years. Some of the better work we've done has been at smartcontract.com, and we've done that work with many different, banks, insurance companies, forward-looking, mid-level, kind of also insurance companies, banks, basically people who deal with financial contracts. And we've gained some perspective on what they're actually useful for. Mm-hmm. So they're, in our opinion, not useful for everything under the sun. They're useful for very specific cases where the unique properties of a smart contract are immediately useful. Usually those properties are along the lines of creating trust or reliability. Before we started building smart contracts about 5 years ago in about 13-14, I was doing some mining. That's how I initially got into the space because in 2011 when I got more interested and actually started putting time and effort towards cryptocurrency. Back then, that's all you could really do is mine or sell, or you could have some kind of e-commerce business selling mm-hmm. something for Bitcoin or one of the few altcoins that seemed reliable. So I mean the real focus for us and our team has been on making smart contracts something useful for real world use cases, and that ended up meaning going towards the places where digital agreements and financial contracts kind of coincide, mm-hmm. and so that's basically where we started doing a lot of work. In the process of doing work of making real world actual value generating smart contracts, we ran into one or two limitations of the space. The limitation that we thought was most pressing was a limitation around providing data into a contract. So that limitation is...
Before we get into that, what is a smart contract?
Oh yeah, of course. Yeah, I think about this. I'm like waking up, going to sleep.
Yeah, it's fine. So let's explain to everyone what a smart contract is to start.
Sure. So a smart contract is, from a semantic perspective, it's not named in the best way, probably, but essentially it's a deterministic digital agreement. So it's deterministic, reliable, tamper-proof. All of these are synonyms depending on the vertical that you're applying the technology to. So the unique property of a smart contract is that it's a digital agreement that provides determinism. It provides a guarantee that the code will be executed as written.
Mm-hmm. It's basically something that you and I, if we enter into any sort of smart mm-hmm. contract transaction, we both agree on what is going to happen based on a set of parameters, and then we write it into code. And if those parameters occur, right, then the code is executed or the contract is executed.
Yeah, that's right. It's different from traditional digital agreements. I think it's important to just highlight the difference. So the difference is that traditional digital agreements are probabilistic. Mm-hmm. So that means that even if performance occurs, even if there's an extreme amount of proof of performance, then somebody could still decide not to fulfill their obligations, right? Mm-hmm. This is...
a bad actor.
Well, a bad actor, yeah, I guess you could call him a bad actor. It's just one of the counterparties decides, I'm not going to fulfill my end of the agreement. I would rather go to court, or I would rather, rely on some other mechanism in relation to how I fulfill or don't fulfill this agreement. Like this happens in insurance, right? In insurance, an insurable event occurs, but you don't get paid, mm-hmm. right? The policy doesn't pay you. In derivatives, it happens where settlement doesn't happen, or importantly, it doesn't happen when it should happen, and when there's a lot of money at stake. That's important because you lose money if it moves between parties too slowly. In other situations like trade finance, sometimes people don't get paid for delivering goods, and other similar situations. So it's those situations where the probabilistic nature of today's digital agreements, in that regardless of how well you code them or how good the software running them is, they're still probabilistic. They still rely on the one of the parties to decide, I am going to pay you on time, or I am going to pay you at all. or I am going to fulfill my end of the contract.
And so in these smart contracts, really what you need to do is you need to have two or more parties come to an agreement. It's written into code, and then you need to understand what those parameters are. Normally those parameters involve some sort of data coming into the contract so that the contract has the information to know to execute or not. But one of the things that you've been spending a lot of time on is where is that data coming from? How high quality is that data? How can you ensure the validity of that data? Maybe just talk through some of the data feeds that go into these smart contracts and why that's a problem in some of the existing projects or blockchains.
Right, so that was the big limiting factor that we came upon when we started making more and more interesting contracts. So contracts that provide more and more value.
Give me an example of one of those really complex ones that you ran into a problem.
So, for example, let's say you want to insure a shipment of some kind of frozen meat or some frozen goods.
Okay, so I'm the insurer, you're the shipper, and you
Right.
say I'm going to ship from point A to point B frozen meat, and I say
Right.
I will provide you insurance
Right.
on that for some cost.
Right.
Okay.
And I'll make sure you're covered as long as I have proof. Right.
Okay.
And instead of managing the results of that somehow through paper or some other way, you can have data from the AAS GPS of a container ship. You can have data from the IoT devices reading temperature in the container, and you can have data about whether something has cleared customs and border protection.
Okay.
So
those are the three data feeds we'll use to know that you did what you said you were going to do.
Right. So those three data. This is a good example because it illustrates an incremental performance. Realistically, in the more academic sense of what we're doing, we're trying to make these complete contracts that are complete because they are triggered by data, and because both parties predetermine that a data feed X is a accurate. If data feed X shows that something has happened, then that's it. They don't need to call each other. They don't need to spend resources to verify anything. The contract can programmatically result in the next step, right? So that's really the goal. And then there's a few dimensions to that goal. One dimension to that goal is there need to be data feeds, and those data feeds need to be provided to the contract. Another dimension is the contract needs to be reliable enough that doing all of this creates enough value that if all of this happens, then the next stage in the contract actually does happen, right? So the piece that smart contract infrastructure provides today is it provides that piece of being able to do a state change. It provides the piece that says, on Ethereum or whatever other network, how do I go from state A to state B, and how do I store that state change in an environment, basically in a data structure or in a network, in the case of smart contracts, that it's so reliable that the other party can drive their own systems off it, can use it for record keeping, do all those things. So that piece is built, and it's built and is getting better and better. That piece is right now getting used for tokenization. So the reason it's getting used for tokenization is because that's the out-of-the-box functionality. So out of the box, you open up a smart contract network, or you use a mainnet network, and you have the ability to tokenize and move tokens and have ownership and do all those things. I mean, realistically, I think that's why there's such a focus on tokenization, because it's the actual functionality you can actually use today, right? It's kind of like the email of blockchains, sort of. If you were to draw an analogy, it's the initial use case that you kind of almost have out of the box. Now, what we're trying to achieve, and what we've been trying to achieve for years, is to take these state changes and tie them to real-world events. Because we feel that tying them to real-world events is where 80 to 90% of digital agreements actually happen. So there's only a small percentage of agreements that relate to purely ownership, that relate purely to, I'm going to transfer token A to person Z over there, right? And then I'm going to transfer token B to another person. I mean, that's useful, and it's absolutely a worthwhile improvement, but it's maybe 10 to 20% of all digital agreements, and that's probably even being generous. The vast majority of digital agreements today, they react to data. So they react to some type of performance beyond asset movement. Now, basically, basically, if we want smart contracts to compete with these other digital agreements, because smart contracts, they have the capacity to be I think, the dominant form of digital agreement, because this property of determinism and this property of reliability and tamper-proofness and cybersecurity, like these properties are very important and they're completely unique to smart contracts. So smart contracts have this property, and I think at the end of the day that can let them become the dominant form of digital agreement. What they don't have in order to be competitive is they don't have the ability to be as useful as a centralized digital agreement. So a centralized digital agreement can access a data feed. It can use a payment system to pay people in multiple fiat currencies. It can send a message to a bank backend or a startup's backend to tell the system something has happened. So I think the really important key point to understand from a technical perspective is the reason that this problem exists is that the very thing that makes smart contracts secure, the consensus that secures that state, which we want to be highly secure and to be highly reliable, that consensus among many node operators, it doesn't allow for any of those node operators to be the source of inputs. So it doesn't have the capacity to designate one of those node operators as the one, like you can't write into an Ethereum contract, go get me a data feed, and then one of the Ethereum node operators goes and gets you that data feed. That just isn't how it works. It isn't how it's going to work because there's various security holes, all kinds of various problems with consensus that just are not manageable.
And so how do we solve that problem today, right? This idea that smart contracts need data feeds in more complex situations, but none of the node operators are eligible or able to go get that data and feed it into the smart contract.
Right. So the way to solve that is you have a designated third party that's designated to be the unique separate node operator called an oracle.
Okay, so this is important because I think a lot of people hear the word oracle thrown around in crypto, but they don't actually know what that means. And so when you talk about an oracle, we've got the smart contract, which is software code that is written. It relies on nodes, right, which is kind of another party, if you will, in this transaction. But now there's a third party, which is an oracle, that is responsible for doing what?
Right. So what the oracle is responsible for doing is basically receiving a request in some form, receiving a request from the requesting contract, and then fulfilling that request, usually for data or some kind of trigger, or some maybe the oracle's supposed to do something out in the real world and then report back. Okay,
so the smart contract is basically sitting there and it says, in order to know when to execute or if to execute, I need data. The nodes that I interact with cannot do that for me.
Can't do
right?
That,
Yep. And so instead, I need to basically ping this oracle to go do that. And so the smart contract says to the oracle, go get me the data feed. So let's go back to our shipping example. It says, get me the GPS data, get me the data from customs, etc. The oracle just pings a data service and gets it, or walk us through how does the oracle actually operate and go get the data feeds that the smart contract needs?
So the way most oracles are built right now, and this varies between chains, but the way it works for most chains right now is that you have an on-chain contract that is kind of the interface. That on-chain contract is the oracle's contract, and that oracle's contract is then sent us. In our system is called Chainlink. So in our system, you have a service agreement going from the requesting contract. And that service agreement defines the relationship between the requesting contract and this Chainlink/Oracle contract, right?
Okay.
That Chainlink/Oracle contract receives the request, and then it can decide, in our system, in Chainlink, it decides if I'm going to commit to fulfilling that request. Once it commits to fulfilling that request, then it's basically on the hook for performance.
So give me an example or a criteria for why would the Oracle not fulfill the request?
Well, that begins to go into questions of how complex the service agreement is. For example, I could send a service agreement to an oracle that asks them to provide me with a data feed they don't have access to.
Okay, got it. So basically, as long as you're asking the oracle, if you're the smart contract and you ask the oracle for data that they're supposed to give you that they have access to, and you don't make any kind of out-of-the-box request, the oracle should fulfill it.
Well, not exactly. There's also a price that you say you're going to pay.
Okay.
And in our system in Chainlink, there's a system of deposits that the Oracle provider puts up to guarantee their fulfillment of the delivery of the data. So there's many different nuances. So the service agreement is actually going to differ based on the industry, because different industries will want different guarantees from their oracles, right? So part of our body of work is actually making a framework where people can request a certain degree of security guarantees from the oracle, right? And those security guarantees can be, I want multiple oracles to validate an input because I want to apply decentralization, because that's the security model of our space. We trust the smart contract because it's basically decentralized. It's run with a high degree of redundancy. And so, I mean, one of the core pieces of our thesis is that you should be able to purchase a certain degree of reliability and redundancy in the amount of in the providing of data to trigger your contract. So one of the key, I mean, once you understand the fact that smart contracts in these networks need an oracle, they can't go beyond tokenization towards insurance or derivatives or trade finance or any of these industries without an oracle, then you begin to think about, okay, well, why should I rely on this oracle? Because in the case of smart contracts, the model of smart contracts, the security model and the threat model and the reliability model is all very different than digital agreements. In traditional digital agreements, there's a bunch of fallback methods. There's a bunch of ways to roll things back and fix things, and all kinds of fallback mechanisms. In the case of smart contracts, the fact that they're so deterministic and the fact that they're so reliable basically makes it so that you also need to trigger them with something reliable, right? If you don't trigger, if you have a highly reliable piece in the middle, then nobody really, well, people care, but what people really care about, what the CIOs, the lead architects, all the people that are actually going to be building high quality financial agreements and the great crypto startups and all those folks, they care about end-to-end security, right? It doesn't really matter if the middle part of your contract is super reliable. If it's triggered in a manner that's easily gamed or easily broken, then the whole contract doesn't.
Well, it's the belief that you're only as secure as your weakest vulnerability.
Well, yes, and
right.
and the idea is that in the case of a deterministic digital agreement, that's immutable and that's very difficult to make changes to later on. That's particularly important because with that determinism, you get efficiency, but with that efficiency, you also get you get a lack of fallback systems. It's just a logical trade-off, and so you should really make sure that the way in which all these contracts function end to end is providing the reliability that would justify people putting actual large amounts.
Okay, and so let's talk about oracles in terms of if I'm a smart contract and I decide that I want to enter into one of these service agreements with an oracle, how do I select who is the oracle, right? Who's responsible for it, who's running it, which oracle to use, and can I create the oracle myself, or does it need to be a third party?
Okay, so there's just a few different nuances there. One of the first nuances is I think to understand how the world looks today and the problems it has,
okay, and
how that can be improved upon, and then to how you select oracles in a more logical manner. So today you don't really have a great oracle service out there. What you have is centralized oracle services run by small groups of people, and most of those are closed source. And the fact that they're closed source creates a lot of problems because you can't validate the quality or the reliability that they're providing, right? You can't know that their method of providing data to you is as secure as the contract, right?
Makes sense.
So that's one problem. Another problem is there are these individual small groups of people that you're basically trusting to trigger tens or hundreds of millions of dollars in value. Architecturally, that just doesn't really make sense, right? What Chainlink seeks to do is it seeks to basically solve that problem by making a framework through which other people can run these oracles. So the
kind of like an AWS for oracles.
Well, the real way to think about it is the logical way to think about it, I think, is that you're mining inputs. So if you're a miner in a main chain, you're mining the consensus and the state changes of that main chain. And if you're running a Chainlink node, then you're essentially mining inputs into that chain. So people are paying you to generate a certain type of transaction that you're putting into the chain. So the point being that if you just want one, you don't want 5 guys in a basement with a closed source piece of software to trigger your $1 billion smart contract. Mm-hmm. That just logically speaking doesn't seem to add up. What adds up more is that, okay, here I have 3, 5, or 10 independently run nodes. Those independently run nodes have a piece of software that's been reviewed by the security researcher community, by tens or hundreds of developers, just like the networks that are actually running my contract, right? So providing those guarantees is really the first step. Then the next step is, okay, I can select multiple oracles, right? If I want to pay, so I'm willing to pay for the reliability of the contract, right? I'm willing to pay for this state change to be secured by hundreds or thousands of people. And today I'm willing to pay a premium for it because, well, supposedly I value that state change being so reliable and deterministic. So if you extend that logic to the reliability of these oracles, then that logic should continue to, yes, I'm willing to pay for triggering the contract reliably. Then we arrive at the question of what does that mean from how many oracles provide you what degree of security, right? Mm-hmm. So how many individual independent node operators provide you a greater degree of security? This is it's an unsolved question. I mean, if you talk to a lot of the smartest people out there in academia at the top universities, and we talk and work with them on a regular basis, it's still a question that's being answered. Mm-hmm. But the important thing we think is that at this stage there's a mechanism by which somebody can say, here's why you can rely on my contract, here's why you can rely on the triggering mechanism. So okay, now we have the ability to select multiple independent nodes running a software that's been audited and is considered to be relatively secure. Then we get into the question of how do I accurately assess which node operators I should rely on. This goes into questions of reputation. So this goes into questions of what has been their past performance, mm-hmm. whose contracts have they serviced. The benefit, the really positive thing about this system is that both the service agreement between the requesting contract and the Chainlink contract, the Oracle contract, is on chain. The commitment to that contract is on chain, and the performance is on chain. So unlike other systems, all parts of the contract are in this one environment, mm-hmm. and all parts of the contract have a cost associated mm-hmm. with them. So basically, what we think you would look at is you would look at, here's a node operator. He has thousands of contracts executed with these top 5 banks and these top 10 startups and those 50 other great companies. And they have he puts up large deposits, to guarantee his reliability. He has a very good track record, and then there can be other forms of proof that node operator can provide to say, I'm in the business of delivering this data to you reliably. Here's proof that I'm running the right software. Here's all the proof that I fulfilled previous commitments to contracts requesting this data from me, or requesting me to execute a payment or to do whatever services, collection of services I'm offering. And yeah, so that we think is the method by which people would choose these operators, and then the operators with better security guarantees would be able to charge a premium for that, and the operators with less security guarantees, they charge less of a premium, but perhaps the security model some people might have would be, maybe I use premium operators for certain things, and I use a large collection of less security guaranteed but more node operators for other operations, right? These are the unknown but very interesting questions. For sure. That we're practically solving of kind of how, yeah. So we're very interested to see how this evolves. Kind of what degree of decentralization do people actually want to pay for once they have the choice of what degree, what amount of decentralization do I want to buy? What quality per node operator? All.
Well, let me ask you this question. Go to the ultimate bull case for smart contracts, right? Let's go out 10, 20, 30 years. Can smart contracts automate every contract in the world?
I mean,
or how big can smart contracts be? How impactful can it be in the world?
I mean, in my personal opinion, I think, I mean, can it run all the contracts in the world? I think eventually there'll be a network effect and there'll be enough value in that. For example, imagine if everybody's revenue was passed through a smart contract and taxes were automatically deducted or whatever other regulatory matters were automatically solved without any need for even a person to be involved, right? Like that's just a way more efficient, way more productive way of working. That's decades, right? That's when governments begin to mandate that people do business in a way that guarantees that they're fulfilling all their obligations to both governments and counterparties, right? So in decades' time, it's probable that, I mean, it's not likely we're going to be going more towards paper, right? We're going to be going more towards digital agreements. Then the question becomes, what is the best type of digital agreement people can have? Today, it's smart contracts, because they're the only ones that have this unique property of determinism and reliability and data transfer and cybersecurity, all these key properties. The properties they don't have are certain properties around, some privacy dynamics, certain scalability questions, and the most immediate thing they don't have is the ability to meaningfully interact with the real world the way that the traditional agreements they're trying to replace do, right? So, but all of those additional features are completely solvable problems. The traditional digital agreements, they can't acquire the unique properties of a smart contract, whereas a smart contract can acquire all the features of these traditional digital agreements. So, I mean, if we're saying, I have every reason to believe that contracts are going more and more digital, even beyond e-signature.
Of course.
I mean, that's just like, at this point, maybe 30 years ago it wasn't an of course. Today it's just an of course. If it's an of course, then
it could be every contract in the world.
I mean, eventually there would be value, right? I mean, if we think about, there's certain contracts where I don't think you need a smart contract because it doesn't solve trust issues.
So this is going to be my argument, is that every contract that should be digital or a smart contract will become a smart contract. Doesn't mean every single one needs to be that.
No, they don't. I think eventually there'll just be network effects. Like at a certain point, you're forced to use certain services as a consumer because other people are on that service. And so I might be doing some kind of business where I have no trust issues. I have no need for these guarantees, but perhaps my consumer has the control of a private key, or perhaps one of the operations my digital agreement needs to happen in a smart contract network for payments release or for data transfer or for something else. At that point, there's just network effects. The more data, the more digital state, the more payments capabilities move into these systems, the more it brings along all the other systems that need to use those capabilities. So it's not an overnight process. If you're asking me about the terminal end state scenario, yeah, I mean, the end state scenario is that if this is the best way to do digital agreements, then it'll encompass initially the types of digital agreements that need this unique capability, and then eventually the cost of running your digital agreement this way will be so low that it'll just be how they're done. I mean, realistically, to think about it, I mean, one of the most exciting things for me personally will be, let's say somebody wants to start an insurance company, or somebody wants to form some kind of company, or some kind of even just a contract that requires a contractual back end. Like today, if I want to form an insurance company in a part of the world where the legal environment might not enforce the insurance policies, I'm out of luck, right? But I think what will end up happening is you'll have all of these people writing all kinds of code that represents contractual backend backends. That code will continue to get better and better, just like open source software did. And
it just removes the uncertainty.
Yeah, it ends up removing the uncertainty, assuming that all the other pieces, like the private key management piece, is in place. The ability for the contract to reliably get access to data, the ability for the contract to pay. So just to be clear, we deal with both the reliability of inputs, which are usually data, various data for market rates to IoT to various data that triggers a contract, and as well as the outputs. So we also deal with how does, what software should you run if you, or what Oracle or what Chainlink should you talk to if you want to do a payment in another chain or in traditional payments environment using banks or something else like that. So we basically, we focus on making the software that makes that possible, and then there needs to be an economic model through which people being good miners, good Chainlink node operators are making a very, very good business out of that. So that needs to exist so that
as well
people provide that service.
So let's do a quick rapid fire of questions before we wrap up. Other than your company, what do you think is the most important company in crypto?
The most important company in crypto. I wouldn't say it's a company. Like, I would probably go towards project.
Okay.
And in terms of the project that, other than our company, of course, but yeah, the company that I think has been making great strides is, it's really between Bitcoin and Ethereum still.
Yep.
That's at the end of the day.
I think it's a great answer.
And choosing between those two is difficult. But if I had to choose one, I would probably go with Ethereum because, they're pushing the limits of what can be done. That's risky. But
what's your most controversial thought? What do you believe that a high majority of other people disagree with you on?
I don't know if I have that. I think the adoption of smart contracts is a thought I consistently push. That people, I don't know if they're surprised or if it's controversial. They just need a clear explanation as to why it's going to evolve that way. I think one of the more interesting thoughts or the conversations that I've had recently is I've consistently been thinking why people from other spaces like consumer or other spaces don't see as much value in smart contracts and in Bitcoin and in these systems. And I think that's a misunderstanding in what this technology does. So I think, and I don't know if this is a controversial thought, but I think it's a relatively interesting one, is that the model that people see from the internet is that they received an interface, and that new interface created a new purchasing dynamic with a large group of consumers, which replaced an old purchasing dynamic, which made these massive companies like Amazon and eBay and all these companies that participated in basically having the right interface, the right user experience interface. This evolution of the internet into like what people still sometimes call an internet of contracts, or a new piece of the internet emerging, this internet of contracts, it doesn't exactly have that. So it's a very back-end heavy problem. And so to appreciate a back-end heavy problem and the significance of a back-end heavy problem, you have to know what back-end problems are being solved. So over the years,
you have to have technical understanding of the problem to appreciate the significance and kind of gravity of it, and if there's a solution.
Right. So this is what I consistently see is over the the many years that we've been working on smart contract. I think that many of the people that work in consumer related things, and this is why I think a lot of people still might not fully see the value of this, but eventually I'm sure that they will, at least myself personally, is that if you work all day on transferring photo files and you're being talked to about a problem related to insurance contracts or these financial backends or these financial contracts, it doesn't resonate with you. You don't know what the extent of the problem is.
Of course.
You can see very clearly that there's incremental gain in going to a store to buy a book versus ordering a book from a website. That you can feel, right? Whereas the gain of basically the people I see realizing the potential of this are the people that understand the actual back-end problems it's solving.
Mm-hmm.
And I think if other people want to truly understand what's going on here, they should look beyond this model of thinking where they're looking at, well, what is the magical interface that blockchains are going to make that is going to replace today?
Of course.
Today's, is it going to be the next mobile? No, it's not going to be the next mobile, right? What it's going to be is it's going to be a new way that today's interfaces, what they do on the back end.
Mm-hmm.
And so to understand the significance of that, you have to understand where today's systems fall short.
Of course. What's the most important book you've ever read?
The most important book I've ever read. I didn't know we were gonna.
I don't warn you. Let's go.
I wish I would have thought of these things.
I want to know what comes top of your mind.
I think probably it would have to go back to some of the earlier books that I read because they probably have a slightly larger effect on you than the things you read later in life. And then I would have to say it was two of Plato's dialogues because they're interrelated because they touch the same point, and that would be the Protagoras and the Gorgias.
Mm-hmm.
So those two dialogues are early on in my life had a certain effect on my thinking about things that I think was significant for me at least.
That's great. All right, you can only answer with a number.
Oh no! Is this like a price thing?
No price.
Okay.
No, I don't care about the price stuff. What is the probability that aliens exist? What are you putting at the probability that aliens exist?
100%.
100%?
100.
I agree.
Life on other planets?
Yeah, come on.
100%. Of course.
My man. All right. Listen, I always end each one with letting the guests ask me one question. What one question would you ask me?
Wow. Well, this is okay. Let me think very quickly, I guess.
Okay.
Where do you think geographically the smart contract adoption will take off?
I'm going to answer with a bad answer, but it's actually globally. It's not in one location. It's in multi-location type transactions. So when you go across jurisdictions, across countries, etc., where you start to involve multiple regulators, multiple jurisdictions of law, etc., smart contracts can be a huge benefit. So, all right, man. Listen, thank you so much for coming. This has been awesome. I really, really appreciate it. And obviously, you've got a very unique view of the world and doing some great work. So I hope we can do this again in the future.
Yeah, I appreciate it, Anthony. Thank you very much.
Absolutely.